Hello, in this video, we will introduce function abstraction and stepwise refinement. We'll use an example to demonstrate function abstraction and stepwise refinement. The key to developing software is to apply the concept of abstraction. You will learn many levels of abstraction from this book. Function abstraction is achieved by separating the use of a function from its implementation. So look at this diagram here. This is function. This is the head of the function. The user only needs to know the head of the function. So what is the input? What is the output from the function? And the body of the function is the black box. This is also known as information hiding or encapsulation. If you decide to change the implementation, the client program will not be affected, provided that you don't change the function header. The implementation of the function is hidden from the client in a black box. You have used many functions such as ret, times. You know how to use all the functions, but you don't need to know how these functions are implemented. So that's the abstraction. It's the details hidden from the user. The concept of function abstraction can be applied to the process of developing programs. When writing a large program, you can use the divide and conquer strategy, also known as stepwise refinement, to decompose a problem into subproblems. The subproblems can be further decomposed into smaller, more manageable problems. We're going to do this example to demonstrate that. This is the example. We're going to write a program that displays the calendar for a given month of the year. When you run the program, you're going to enter the year and the month. It displays December 2014. This is the calendar for December 2014. Let's use this example to demonstrate stepwise refinement. We're going to use the top-down design strategy to design the problem. So we know the problem now. The specification is very simple. And now we're going to design how we're going to produce the output. How would you start such a program? Would you immediately start coding? Beginning programs often start by trying to work out the solution to every detail. That's really overwhelming. You need to look at the big picture, then get down into small details. Although details are important in the final program, concern for detail in the early stage may block the problem-solving process. To make problem-solving flow smoothly, this example begins by using function abstraction to isolate details from design. Only later does it implement the details. We can now break this problem, print calendar into two subproblems, read input and print month. Further, we're gonna break the print month problem into print the month title and print month body. And now, how do you print the month title? We need to know the month name. How do you print the month body? We need to know the start date in that month and the number of days in the month. Now, how do you get the start date? To get the start date, we need to get total number of days. So here is how do you find the start date? If you know one day in the history, in the calendar, and then you can derive with all this every other month, the first day. So let's assume that we know the start date for January 1st, 1800 is Wednesday. So that is start date. From that start date, we can get any start date for any month afterwards. But you need to know the total number of days since January 1st, 1800 to this month you need to print. So this is to get the number of days and get total number of days. Now we need to know is a year is leap year. So we look at every year now since January 1st, 1800. So, and see if it's leap year, and the leap year is 366 days, and non-leap year is 365 days. So we also need to get number of days in month. So for this, January, 31 days, February, if it's leap year, it's 29 days, if non-leap year is 28 days, and then for every month, we need to know this. And now we also need to know is leap year in order to get number of days in month. So we put all this into now big diagram here. So this is all the design diagram. So we're gonna get this read input. That's very easy, so we don't have to continue the bracket. And for the print month, so the bracket into print month title, print month body. For print month, we will get month name. Print month name, we will do get start date. And then get start date, we need to get total number of days. And this is get total number of days. Here is get the number of days in month. And so this where it is leap year. We already know how to implement is leap year from chapter 3. So this is design structure chart. Each box in the chart can be implemented using a method, using a function to implement it. If a function is too simple, like this read input, we can combine it with its parent function. So in the main, let's have this now. We're gonna now implement it. So we can use either the top-down implementation or the bottom-up implementation. Top-down implementation is going to start from the top. And for the things we don't know how to implement it, we can just have a stub. It's called like skeleton. You don't have to fill in the details just for now. And this is the stub. A stub is a simple but incomplete version of a function. So now let's look at the stub here. So we have this, it's print month title, print month name, print month body. So all of those functions now are defined. And now the main function, we're gonna prompt the user for the input, the year and month, and now print month. And here now, this print month, this we just gave this is the stub. This is not a completed detail. So when you implement it, so you're going to look at the detailed now for this is leap year, and this is, we already know it, and the leap year is this year is divisible by 400, or the year is divisible by 4, but the year is not divisible by 100. So that is a leap year. So that's one here for the is leap year. Now for all the others here now, we're going to now have everything is implemented. Now this is the top-down approach. Bottom-up is this. You can begin to implement one module at the bottom. So first is leap year, and then test it, and then go up and to implement all of this all the way to the top. So that is called a bottom-up approach. And this is the everything here in this. Implementation now. So let's look at the benefits of stepwise refinement. Stepwise refinement is also called the divide and conquer. It breaks a large problem into smaller, manageable subproblems. Each subproblem can be implemented using a function. This approach makes the program easier to write, to reuse, to debug, to test, to modify, and to maintain. Simple programs now. The print calendar program is really long. Rather than writing long sequence of statements in one function, stepwise refinement breaks it into smaller functions. It simplifies the program and makes the whole program easier to read and understand. Reusing functions, stepwise refinement promotes code reuse within a program. The isLeapYear function is defined once and invoked from multiple functions. This reduces redundant coding and easy debugging, developing, and the testing. Since each subproblem is solved in a function can be developed, debugged, and tested individually. This isolates the errors and makes developing, debugging, and testing easier. When implementing a large program, use the top-down and bottom-up approach, or bottom-up approach. Do not write the entire program at once. Using this approach seems to take more development time because you repeatedly compile and run the program, but actually it saves time and facilitates debugging. So you know where the problem is, and the code you just added caused the problem, so it narrows the scope for debugging. Better facilitating teamwork. Since a large problem is divided into subproblems, the subproblems can be assigned to other programmers. This makes it easy to work in teams. That is all for this section on function abstraction and stepwise refinement. Thank you for watching. See you on the next video.